Hello everyone, happy to see you here. Welcome back to my channel, Hi Mathematics. Today we have very interesting and in the same way, this is very tricky algebra question. We need to find which number is larger. On the left side we have 1.1 to the power 10 and on the right side we have 2. So right now let's test our intuition and write your solution down, write your assumption down into the comment section and then we will check your answer. So it will be really interesting. On the left side 1.1 to the power 10, on the right side we have 2. So which one is larger? Here is our solution. So first of all, a lot of students might be thinking, okay, let's write this 1.1 to the power 10 like that, okay? They say, okay, we can easily write it as 1.1 times 1.1 times 1.1. A lot of students might be thinking that this is a solution, but this is a long way. How can we solve this question? And I don't recommend you this approach. So a lot of students might be thinking, okay, right now I'm going to multiply this 1.1 times 1.1. So right here, of course, we have 10 times. Yeah, so with the basic method, so we're going to raise this 1.1 to the power 10. I don't recommend you this method. So instead of this method, I'm going to show you this one. This method is called method of like binomial approximation. So first of all, instead of this 1.1, we can write really important expression for us. Okay, so we have 1.1 to the power 10. Instead of this 1.1, we can write in parentheses, we can write sum. We can write 1 plus 0.1 to the power 10. And right now we can easily apply method of binomial approximation. How does that method looks like? For example, we have a sum 1 plus x. So we have 1 plus x to the power n. Okay, this is our main formula. I just write this how this method looks like. And this sum is approximately equal to 1 plus n times x plus n times n minus 1, we divided by 2 and times x squared, and we have a lot of high ordered terms. So we need to plus higher ordered terms. Okay, so this how our formula looks like. Okay, so we have a sum, we need to raise this to the power n, but we know everything. We know x, so right here, but x is equal to 0.1 and n is equal to, so n is equal to 10, okay, because we need to raise this to the power 10. And right now let's find our first few terms. Okay, let's find our first few terms. So the first thing, we're gonna find linear term. We're gonna find linear term. Linear term is right here. So this is our linear term. This is n times x. As a result, we can easily multiply our n times x. So our nx is equal to 10 times 0.1. As a result, this is equal to 1. So our linear term, this term, equal to 1. Right now, let's find our quadratic term. This term, let's find our quadratic term. So second thing, we're going to find our quadratic term. Okay, we're going to find our quadratic term. Okay, let's plug in each of these elements into this spot. So we need to n times n minus 1. As a result, we can write it as n times n minus 1 over 2 and times x squared. Let's plug in each of these elements from here. We know x, we know n, so as a result, when we plug in n, we have n equal to 10 times 10 minus 1 equal to 9, and we divided by 2 and times x squared, but x squared equal to 0.1 to the second power. So let's find our quadratic term. This is equal to, as a result, we have 10 times 9, we have 90 over 2 and times, right here we have 0.1 to the second power equal to 0.01. And as a result, this is equal to 45. And when we multiply our 45 by 0.01, this is equal to 0.45. So this is our quadratic term, this is our linear term, and this is our quadratic term. And of course, our final step will be finding a cubic term, like for better accuracy. Okay, let's do this. For better accuracy, let's find our cubic term. Okay, we don't have right here this cubic term because I just summarized this as a higher order term, but right here we have cubic term, we have fourth power term. You know, we have a lot of these terms because it helps us to find our answer with the better accuracy. But right now, let's find find our cubic term. Yeah, let's find our cubic term. Let's find our cubic term equal to. So as a result, I don't want to write this formula. As a result, we have 10 times 9 times 8, because this is our cubic term. So we have 10 times 9 times 8. We're going to divide it by, not right here 2, we're going to divide it by 3 factorial. This is our 6. And times, right here we have 0.1 to the power 3. So this is our 0.001. Yeah, we have 0.01 to the power 3. As a result, we have 0.01. Yeah, and right here we have 90 times 8. We have 720 divided by 6, and times we have this one, 0.001. So right here we have our cubic term. This one is equal to 0.12. And right now let's find our approximately answer. We have right here our formula, so 1 plus x to the power n. So this formula, 1 plus 0.1 to the power 10. Okay, let's summarize what we have. So 1 plus 0.1 to the power 10. According to this formula right here, we have 1 plus linear term plus quadratic term, and we find for better accuracy, we find our cubic term. So let's add all of this. So we have 1 equal to 1 plus, right here we have our linear term nx equal to 1 plus 1, plus our quadratic term. This is our quadratic term. We find it right here, quadratic term equal to 0.45. plus 0.45, and plus, for better accuracy, we found our cubic term equal to 0.12. Of course, we can find our fourth power, fifth power, like for better accuracy, but in this point, we can easily see that our expression is bigger than 2, because we have 1 plus 1 equal to 2, 2 plus 0.45 equal to 2.45, and plus 0.12 approximately equal, of course, right here, the sign of approximation, equal to 2.57. Okay, and this expression that we found in the beginning equal to 2.57, and of course, for better understanding, we need to add to this higher terms, higher terms. And with all of these higher terms, this answer will be approximately equal to 2.57. And since the higher order terms are positive and small for x equal to 0.1, the total is slightly more than 2.57. Of course, slightly more than 2.57, which is clearly greater than 2. So I'm going to write it, I'm going to underline all of these things right here. So we have, in the beginning, we had 1.1 to the power 10, and we have 2. As you can see right here, we find the approximately value of this 1.1 to the power 10 equal to 2.57. So this is approximately equal, left side approximately equal to 2.57, and on the right side, we have 2. So since 2.57 is greater than 2, we can conclude that 1 to the power 1 to the power 10 is greater than 2. So the binomial approximations shows that even the first few terms exceed 2, and additional terms only increase the value. So at this point, when we find a quadratic term, we're going to have like 1 plus 1 plus 0.45. We can easily see at this point, that our left side is greater than 2. So in conclusion, I want to say that our answer 1.1 is greater than 2, because our 1.1, according to a binomial approximation, is approximately equal to 2.57. And this is my solution to this question. I'm going to show, I really want to show you this method of binomial approximation, because this is like a basic one method. And as you can see right here in the beginning, I said that we can easily multiply it 10 times by each other. Okay, we can easily do that, but this is not the best way to solve this question. Of course, you can easily, if you don't know any of this method, you can say, okay, I want to multiply 1.1 times 1.1 times 1.1, a lot of these signs times 1.1, and to be honest, honest, this is not a good method for your teacher, because if you solve this question like that with binomial approximation, it's much better for you and for your teacher, because just agree with me, when you have this long pattern 1.1 times 1.1, it's not that easy to multiply it. Okay, it's much easier to multiply it with the fraction. So we have 11 over 10 times 11 over 10, or something like that, but this is not the good method. Just forget about it and learn about this binomial approximation. So just forget about this method, because this method takes a lot of time, to be honest. When you multiply it and multiply this type of expression by each other 10 times, it takes a lot of time, to be honest. Yeah, and let's write our final answer to this question. So our final answer, our 1.1 to the power 10 is greater than 2. You can easily share your method down into the comment section. I'm really interested when you see your method. This is my method according to a binomial approximation. So I'm going to put it out there. You can easily see it. This is our main formula, equal to 1 plus linear approximation plus quadratic approximation, and of course for better accuracy you need to find cubic terms and the force power terms. Sometimes happen that you can't 100% say with 100% probability which one is greater, so we need to find the force power term or fifth power term. But in our case we need to find our linear term. We can easily see it right here. This is our linear term, this is our 1, and this is our 2, this is our quadratic term. And for better accuracy I just found our cubic term. Okay, we have our cubic term right here, and in the end we're gonna add all of this stuff. As you can see right here, at this point, when we have 1 plus 1 plus 0.45, we can easily see that our expression is greater than 2 at this point. So we don't need this cubic term, but for better accuracy, as you can see, we find it. And if we find the force power term, we will have like our exact value will be like more accurate to this expression 1.1 to the power 10. So once more, my solution here you can see. I recommend you to forget about this raising to the power 10. Just learn this binomial method, just split it in terms of like addition, and of course learn this formula. Okay, this is my solution to this question. So I really want to say thank you for watching this video, for supporting my channel. I really appreciate it. If you like this video, if you don't like, you can easily write to respond. You can easily leave your like or dislike. I really appreciate your response when you mention what's going on in this video, when you underline all this mathematics stuff. It's really great to see your feedback, to see your response. What do you think about this type of solution? And of course, if you have your solution, it's much greater to share your solution down into the comment section, because maybe a lot of students watching my channel, a lot of teachers watch. And of course, if you have a question, it's really great to see a lot of solutions, because maybe one part of students like doesn't understand this type of they want to see another one. It's really great to exchange information. So thank you for your time. Wish you all the best in life. Take care of yourself and have a great day. See you in the next videos.